Hello YouTube, this is MatriXcel working on behalf of Night Bloom Vision to bring you your 5th C++ tutorial. Alright, so in our last tutorial we talked about arithmetic types such as ints and floats, and I said in that video that I was going to talk about data storage and how these variables are represented at the low level. So that's what I'm going to be talking about today. When you're dealing with a low-level language like C++, it's very important to understand these low-level details such as pointers, how memory is managed, and everything. And this will be an essential tutorial, so I suggest you watch it through and through. So without further ado, let's get started. Okay, so here's a brief refresher of something we did in the last tutorial. We did something like this, and this created a variable named a of type int, and we stored the 5 into that variable. And remember, integers can store positive and negative whole numbers. And by the way, please, when you're making programs, don't name your variables like I did. I just named it this way because this is just a tutorial and I'm just trying to, and that's not really the point of emphasis here, but the point is that you should name your variables, give your variables meaningful names. Like for example, if you're starting the speed of a player in the game, you want to name your variable player speed or something of that sort, not a, because it doesn't make any sense. And when other people are reading your code, they're gonna look at it and be like, what is this supposed to mean? So yeah. Okay, so let's get started. So how are numbers and data stored in memory? Well, you probably know it's stored as zeros and ones because the CPU, unlike humans, can only understand zeros and ones. We humans use a number system called base 10, or the decimal number system, which means we use 10 digits, 0 through 9. Okay, so we probably learned it back in grade school how to do something like this. So if you have a number 15, we learned that we can decompose this into a more primitive form, since we know that we have 5 in the ones place, and then we have 110 in the tens place, and that makes 15. You can also put this is 10 to the 0, 10 to the 1. Okay, so 10 to the 1 is what? 10. 10 times 1 is 10. So we do 10 to the 1 times 1 plus 5 times 10 to the 0. And sorry for this bad writing, because I'm using this program because I don't even have a tablet available to me right now, so just bear with me. And then you get what? 15. And then you can, if you keep adding, going further to the left here, you just get incremental powers. You get 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, so on and so on. So you get the point. Okay. So in binary, binary is a base 2 number system. So you only have a 0 and 1. You don't have 10 digits available to you. You only have a 0 and a 1 because it's base 2. Alright, so we have a binary number that goes something like this. This will be 2 to the 0th power, 2 to the 1 power, 2 to the 2 power, and 2 to the 3 power. And you can see a pattern again. So the base here is the base we're in, as you can see. So that's where we get the word base from, the base of the exponent. So you see, so this here in this case is 2, and 2 to the 0 gives us 1. 2 to the 1 gives us 2, 2 to the 2 is 4, 2 to the 3 is 8. So yeah, just our base 2 number system. So how do we interpret this? So the way we interpret this is it's basically the same way as we did with base 10. It's just we do 2 to the 0 times 1 plus 2 to the 1 times 0, which will just be 0 because we don't have anything in that place. And then 2 to the 2 times 1 plus 2 to the 3 times 0. So 2 to the 0 times 1 is just 1. Plus 2 to the 1 times 0 is just 0. Plus 2 to the 2 times 1, which is just 4. And 2 to the 3 is 0. So we get what? That's 5. So that's how you represent 5 in binary numbers. Alright, so we call each binary digit a bit. So that's what, so in binary we call each digit a bit. So this 1 will be 1 bit, this 0 will be another bit. Yeah, it's just another word for binary digits. So in RAM, or main memory, our values are actually stored as groupings of 8 bits. So each grouping of 8 bits in memory is actually associated with a certain address. So for example, this value 5 right here may be stored at the theoretical location like address 0, let's say. That's not the point here, but let's just say it's stored at address 0. And so it'll take 8 bits to represent this number 5. As you can see, we represent the value 5 in 8 bits. And it started at the address location 0. So not to add more meaning to variables, like variables are like a higher level abstraction in C++ that allows us to refer to certain values stored in memory by a certain name and not by like a address. So imagine having to refer to the number 5 by like some arbitrary location like 5, 6, 7, 8, 9, 1 or whatever. That'll be very painful, and we don't want to refer to memory location by their addresses because it doesn't have any meaning to it, and it's just very hard to understand. So we have these named variables, like we can name it a certain location in memory like player speed, and then that will add a lot more meaning than just referencing some random address in memory, for example. So variables are a certain high level abstraction we use to give meanings to these values stored in memory. And in memory, each value is stored as there's each grouping of 8 bits has a address location associated with it, and we use variables as a higher level abstraction to give a named name to these addresses. So that's the basic idea of it. So each grouping of 8 bits is also called a byte in binary. So this right here would be 1 byte. So keep in your head that 1 byte equals 8 bits. So an int in C++, an integer, can actually store up to 4 bytes of memory, which is 32 bits because 4 times 8 is 32. So what's the maximum number you can represent with 32 bits? Well, we know that, well, you don't know, but you will know that if we turn all the bits on, if you have 8 bits, okay, so if you have 8 bits right here and we turn on all the bits, the maximum value we can represent with 1 byte is 255. 255. Or in other words, 2 to the 8th power minus 1. So 2 to the 8 meaning we're using 8 bits. So the maximum number it can represent is 2 to the 8th power minus 1. So, and the combination of numbers they can represent is actually 256, which is including 0. And we subtract 1 from it to get the maximum number, which is 255. Okay, so how many numbers can 32-bit integer store? So let's do 2 to the 32 minus 1. I don't know the answer off my head, so and now you just use a calculator. 2 to the 32 is this one. Yeah, so that's a huge number. You can represent up to 4,294,967,295. That's a huge number. So that's the maximum number an integer can represent. Again, we say 32 here because we want to see how much a 32-bit number can represent, which is 32 bits is what? 4 bytes, and 4 bytes makes up an integer. So that was just a brief lesson on data storage. We'll continue more in the next tutorial. In the next tutorial, I believe I'll be talking about signed and unsigned integers. Yeah, so look forward to that. Subscribe below, comment, join our Discord if you have any questions, donate to our Patreon, and I'll see you in the next tutorial. Thanks for watching.